Hello, and welcome to week number 15, pre-college math. First thing I want to talk about today is week 15. Week 15 is a long week, just like it was right before Thanksgiving. This week we have a main lesson. It's December 13th today. But next week on Monday, we don't have a main lesson because there's no new material next week. You have until next week, Wednesday, the 22nd, to turn in all the work for this week to be on pace. But if you get it done before then, like let's say you get everything done by Tuesday or Wednesday, you don't have anything to do next week because there's no new material for next week. This week we're going to be talking about functions, polynomial functions, how to be able to tell what the end behavior is just by looking at the function, and also what the degree is, how to graph a polynomial function of a higher degree, and how to write a polynomial function with a higher degree. So the graph of polynomial functions are classified by the degree of the polynomial. Each graph based on the degree has a distinctive shape and characteristics. So first degree is always a linear function, second degree is quadratic, third degree is a cubic, fourth degree is a quartic, and fifth degree is a quintic. The zeros of a polynomial function are where it crosses the x-axis. Now, what you're going to have to be able to do today is you're going to have to be able to identify the leading coefficient and describe the end behavior of a function just by looking at its function or its degree and its leading coefficient. So in this problem, the degree is 2. So I know that the end behavior is only going to be this way or this way, and it all depends on the leading coefficient. If the leading coefficient is positive, my end behavior is going to go up on both sides. If it's negative, it's going to go down on both sides. Now, that will go with any polynomial function that has a degree, an even degree. It doesn't matter if it's 2 or 4 or 6 or 8. For example, if I gave you something like 5x to the 6th plus 7x minus 3, it's not going to look like a quadratic because it's a 6th degree, but I do know that it's going to look something, the end behavior is what I know is going to go up because it's an even degree and a positive leading coefficient. So in this problem, the leading coefficient is positive, so the end behavior is going to go up on both sides. So what we usually say is as x approaches positive infinity, y approaches positive infinity. So it's going up. As x approaches negative infinity, y is approaching positive infinity again. In this problem, the degree is positive, so it's a second degree, or it's even, and the leading coefficient is negative this time. So I know the end behavior is going to go down. It's going to look something like this one. So the end behavior is going to be as x approaches positive infinity, y is going to go to negative infinity. As x approaches negative infinity, y is going to go to negative infinity. Now, if I have an odd degree, okay, so my degree is 3, which is odd, and a leading coefficient that's positive, well, now I have to start looking at a function that looks like this, okay? All functions, so if this is an odd degree and a positive leading coefficient, the end behavior is going to go up on the right side, down on the left. If it is an odd degree and negative, then the end behavior will look more like this, where it's going down on the right and up on the left-hand side. So just by looking at a polynomial function, knowing what its degree and leading coefficient is, you know what the end behavior of that graph is going to be. You might not know what the graph looks like, but you should know what the end behavior looks like. So in this problem, it says identify whether the function graph has an odd or even degree. Well, if I look at this one, the first one, it kind of resembles this graph here, right? That's how the end behavior is looking. So that means that this has an odd degree. The leading coefficient is going to be positive. In this problem, since it's looking like a parabola, it's going to have a, let's say, even degree, because it's not asking if it's 1, 2, or 3. The leading coefficient is going to be negative because it's going down. In this problem, it looks very similar to this one. So that means it has an odd degree and the coefficient is negative. So just by looking at a graph, and that graph could look anything like, could look something like this. Well, if it's going down on the left side and up on the right-hand side, it's going to look very similar to this one. So it's going to be an odd degree with positive leading coefficient. Identify the leading coefficient, degree, and behavior. Well, in this problem, the leading coefficient is -1, and the power, the degree, is going to be even. So what's the end behavior? Well, it's going to look something like this. Even degree, leading coefficient negative. So I know as x approaches positive infinity, y is going to approach negative infinity. As x approaches infinity, y is going to approach negative infinity. Now this one's a little bit trickier. This is a third degree here, second degree here, first degree here. So if we add up all the exponents, 3, 4, 5, 6, this is an even degree polynomial. And I know that if I multiply all the first terms together, it'll give me the leading coefficient. 1 times 1 times 1 is 1. So the leading coefficient is positive. So I know that, I don't know what this graph is going to look like, but I know that its end behavior will look something like this. Now, I can get a little bit better because I know it has a 0 as an intercept. I know it has +2 as an intercept. And I know it has -1 as an intercept. Now, since this is a second degree and this is a third degree, when it crosses the x-axis, it looks something like this. It'll come up and it'll look like that. If it's a second or fourth or sixth, it touches and then goes back up, or it touches and goes back down. So in this problem, I know so it's going to x to the third, so it's going to come down. So this is, so -1, so it's just going to cross over here once. Then it's going to come up, and then it's going to make like an S shape here. It's going to go up, and then it's going to touch and go back up. Why does it touch and go back up here? Because it's a second degree. If it was a fourth degree, it would do the same thing. If it's a sixth degree, it would do the same thing. So that is what my graph would look like. So this, if you plug this into your calculator, you'll see that it will look like this. Guaranteed. So graphs behave differently at various x-intercepts. And the reason they do is because of the power. It's a multiplicity kind of thing. If it's a first degree, it just goes right through. If it's a third degree, fifth degree, seventh degree, it's going to look something like this. It's not going to go through nicely. It's going to make like an S shape there. So this would be a 3, a 5, a 7. Now, the higher the power is, the flatter it gets here. Okay, it would stay longer and then go up. But if it's just a third degree, it just hits and goes up. If it's a second degree or fourth degree or sixth degree or eighth degree, any even degree, it's going to hit and go back up. Now, if it was like an eighth degree, it would hit and it would be more flat and then go back up. But it would not cross the x-axis like mine does. So if I wanted to write an equation for this thing, which on your assessment, it does ask you to write an equation, you just look at where it crosses the x-axis or touches the x-axis, and that helps you out immensely. So if I was going to write an equation for this thing, it's like x, so I know that this is going to be x plus 2, and it's to the first power. Here, so that's going to be x plus 1, but I know it doesn't cross nicely, but I know it has to have an odd power, so I'm just going to use 3. And then here at 2, so this is going to be x minus 2, and it doesn't cross, so it's an even degree, so we'll go 2. So this is my polynomial function. Graph it out, plug it into your calculator. You'll see it's going to look just like that. So the practice for this week, problem number 1, says identify the end behavior of the polynomial function. Now, this polynomial function and this is the same thing. So I can look at this, tell you what the end behavior is, or I can look at this and tell you what the end behavior is. It doesn't make any difference. I mean, here I know the leading coefficient is positive. Leading coefficient is positive, and the power is odd. And so I know it's going to look something like this. So the end behavior, as x approaches positive infinity, the y is going to go positive infinity. As x goes negative infinity, the y goes to negative infinity. So as x goes positive infinity, yes. Negative infinity, no, that does not work. As x goes to negative infinity, no, that does not work. As x goes to negative infinity, y goes to negative infinity, yes, that works. As x goes to positive infinity, y goes to positive, yes. So letter C for problem number 1. Number 2, it says which polynomial function graph below has an end behavior that is different from the rest? Well, it goes up, down, up, down, up, down. Huh. This one is not the same. These all have the same end behavior. This one does not. So I'm going to go with letter D for number 2. Number 3, it says identify whether the polynomial function graph has an odd or even degree. Well, it has to be odd. Why is it odd? Because it has the end behavior looks something like this. That is either a 1, a 3, a 5, so that it has an odd and a positive or negative coefficient. Well, this has a negative coefficient. So even degree, nope. Odd degree, yes. Negative leading coefficient, absolutely. Boom, right there. From which of the following intervals does the graph h of x appear to be increasing? Well, a function increases and decreases, you just read from left to right. So here it's decreasing till it gets to here. Oops, turn my marker. Then it increases. So it increases from -1 to +1. So -1 to +1, it's increasing. And it's also increasing from 3 to infinity. So there's my, what I would say would be where it's increasing. So -1 and then 3 to infinity. I'm going with letter B for that one. Determine the zeros and end behavior of the polynomial graph. Zeros are where it crosses the x-axis. So those are pretty easy to find. So in this problem, crosses here at 3, at -3, sorry about that. Crosses here at 2, and it crosses at 4. Those are my zeros. And then it wants to know what the end behavior was also. Wasn't that? Is that the other question? And end behavior of the polynomial. So -3, 2, 4, yep. At the end, behavior is left to right. That doesn't make any sense. End behavior is y approaches negative, no. I suppose they could write it backwards, I suppose. So as y approaches negative infinity, x approaches negative infinity. No, that's not right. End behavior is y approaches positive infinity. So the y goes to positive infinity as x approaches negative infinity. Yep, that's right. And y approaches negative infinity as x approaches pi. Yeah, I'm going to go with letter D. They kind of write it out a little weird. It's usually it's x as x approaches positive infinity, y approaches. So kind of backwards there, but same thing. Use the graph below to write a polynomial function in factored form. Okay, so factored form. That's really easy. All you have to do is find out where it crosses the x-axis. Looks like it crosses, so this is going to be x plus 2, x plus 1, and 1, 2, 3, 4, 5, x minus 5. Now, the only thing I need to know is, so this is 1, 1, 1, so this is a third degree. So look at my end behavior. It's going down. So that means the leading coefficient has to be negative. I don't know what the negative number is, but I know it has to be negative. So I look up here, and it looks like this is the only one that has a negative leading coefficient. So I know this one has to be right because it's the only one that has a leading coefficient that is negative. Which is a graph of an even function with a positive leading coefficient. So I'm looking for end behavior that has to look like this. It has to go up on both sides. This is the only graph that the end behavior goes up on both sides. So that means it has an even degree and leading coefficient is positive. Which is the graph of polynomial function? Let's see here, I can barely read that. X minus 1, so I know that x equals 1, x equals -1, and x equals 4 are 0, so it crosses, and the leading is positive, so I know it's going to look something, the end behavior will look something like this. So this one, it could be this one, and it could be this one. So now which one crosses at 1? Let's see here. So that one doesn't. So cross that -1, 1, and 4. So I'm going to go with letter D for that one. Which of the following polynomial functions could have the graph shown? Okay, so I know it has to have an even degree, and I know the leading coefficient has to be positive. So this one here, change my marker, this one can't be right because this is a 3rd degree polynomial. Can't be right. This one is a 4th degree polynomial, and that one looks like this is a 4th degree polynomial also. So let's see where it crosses. So I know it has to be x plus 1 quantity squared. Why is it squared? Because it doesn't cross. So it has to be higher than 1. Then I also know that this has to be x minus 2 and x minus 5. So that would be my polynomial function if I had to write out real quick. So x plus 1 squared, x minus 2, x minus 5. Yep, letter B would be the correct answer. Which of the following polynomial functions could have the graph shown? Okay, well again, I just look at the end behavior, and the end behavior is going to represent something like this. It goes up on the right, down on the left. So I know it has to be an odd degree, and I know the leading coefficient has to be positive. And it has to cross, so I'm just going to write out the equation, x plus 2, and then this is going to be a 2nd degree, so that's going to be x minus 1 squared because it touches and goes back up. So my equation is going to be x plus 2, x minus 1 squared. And that looks like this one. They just didn't write it out in that form, but I like A. Once you finish with this week's work, you're on winter break. We don't meet back until January 3rd. So have a great winter break. Bye.